Let's look into the tips and tricks of the subject. Every subject has some tips and tricks. You have to know it. When you're preparing for a competitive examination, it is a must to know it. So let us look into the subject. When you're dealing with Boolean algebra, the basics or the Boolean algebra, the first thing is, okay, you should know a technique of substitutions. Okay, it's a very important tip or a trick, you can call it. Whenever there are big equations or whenever you got stuck in some combinational analysis, there's a big circuit you're analyzing, you're doing something and you got stuck somewhere in between, then to validate it or to rectify it or to identify the mistake or to come out of that problem, the best way is substitution. Since we know every Boolean algebra will assume zeros and ones. Okay, so simply substitute zeros and ones and just rectify the problem immediately. This is one of the techniques. Most of the students will be lacking it. Or whenever there is a big Boolean expression, okay, and if you want to get the result from it, so simply substitute certain values, you will get some other values, and substitution will be very easy in this Boolean algebra way, because everything is zeros and ones. The ultimate result of any Boolean expression or any logic circuit should be 0 or 1, okay, because this is a pure digital. So don't forget, so while working especially with the Boolean algebra or with some certain circuits, whenever you are finding it difficult, okay, then think of substitution of values, that is, put some signal values and try to get some other signal values, okay, so that easily you will come out of that problem. So this is the first thing or the first tip which you have to know. Now, when you are working with especially combinational circuits or sequential logic circuits, you have to be very good at logic gates, the basic definitions of logic gates. You should be very good. When the AND gate will be enabled, when the AND gate will be disabled, or when the OR gate, or when the logic gates will be enabled, when the logic gates will be disabled. Okay, what is the truth table of the logic gate? What is the truth table output column of the logic gates? These things, if they are on your fingertips, that will be very easy for you to analyze the networks. So don't forget, don't think or don't assume that you know AND gate, NAND gate, I know perfectly, but when it comes to a circuit, then you will be unable to do, or you will find it difficult. Why? Because maybe because of your overconfidence, or maybe because you are lacking in the basic definitions or basic truth tables or basic analysis of the logic gates. So don't forget these things. Now coming to identifying the universal gates. Most of the students will be in a myth that NAND and NOR gates are only universal gates. Now I will tell a simple question. I am just drawing some logic gates. I am just making some small logic gates. You can just say there are certain logic gates I have drawn. Now, generally these type of questions, what I am asking, now they can ask in interviews, or they can ask, there is one gate question also based on this concept. Now I want to find out the universal gates. There are certain gates, some 8 gates are the 8 logic gates are the 2 input gates. I want to find out which gates are universal, which gates are not universal. The first gate, is it universal? Check yourself. Yes, everyone knows this is a universal. What about this? Is it universal? What about this? Is it universal? What about this? Yes, it is universal. This everyone knows, it is universal. It is simple NOR gate, this is an AND gate. NAND and NOR are always universal. Okay, what about this gate, this gate, this gate, this gate? So how to find which are universal, which are not universal? I am telling a simple technique or a trick or a tip. Now the trick to find out universal gates is, whenever there are AND symbols and OR symbols, whenever there are AND symbols or OR symbols, there is a two input, okay. Whenever there are some AND symbols or OR symbols, okay, whatever the gate, okay, I'm just, okay. Whenever there are AND symbols or OR symbols, okay, some gates, you can draw whatever you want. Remember, whenever the AND symbols and OR symbols are there, during that time only, you just check for the number of bubbles. If there are one or two bubbles in the complete logic gate, then it is universal. You can just hear. So AND symbol is there, one bubble is there, universal, that you know. And you can just hear, there is an AND symbol, there are two bubbles. One bubble or two bubble in the circuit, it is universal. So this is also universal logic gate. This is also universal logic gate because two bubbles. This is universal, one bubble. Of course, this is a NOR gate. And this is also one bubble, universal. There are two bubbles, universal. And this, there are three bubbles, not a universal logic gate. What about this? This is also not universal because there are three logic gates. So the technique in finding out the universal logic gates is, whenever one bubble or two bubbles are there, that is simply universal. But symbol should be AND or OR symbols. That's it. So how you got, and okay, why exactly? So don't be under impression that NAND and NOR are always universal. No, there are some other gates which are universal. These are not a NAND gate, this is not an OR gate, but still they are universal. You can just see that. Why they are universal, how they are universal, how to validate it is a part of classroom course. Okay, but remember this technique, it will help you. Now, coming to the realization using mux. Now next technique or the trick or the tip, what you have to remember when you are handling multiplexers, decoders, demux and ROM. So these devices, the combinational devices, the mux, demux, decoder as well as ROM. Multiplexers, as I told that using this mux, decoder, demux, ROM, you can implement Boolean expressions. You can implement whatever you want. So remember, whenever you want to implement Boolean expressions using these four combinational devices, the trick what you have to remember is, for the multiplexers, the trick is, if you want to implement a Boolean expressions using multiplexers, the function variables of any function, the function variables will become the select lines, the function will become the output of the mux, and the function values will become the data inputs. That is simple trick to implement Boolean expressions using mux. Now coming to the decoders. If you want to implement Boolean expressions using decoder, the technique is, the function variables will become directly the inputs of decoder. That's it. Now coming to the demux. As we know that demux is nothing but is a decoder with an enable input. So whenever a question comes from demux, assume that it is a decoder and solve it. And for demux, remember, for a demux, the select lines will be function variables. Or if you want to implement anything using Boolean expressions using demux, the function variables will become the select lines of the demux. Now coming to the ROM. The unique speciality of the ROM circuit is multiple Boolean expressions you can implement using a single ROM. That is a one speciality of the ROM circuit, the read-only memory circuit. So here the technique what you have to remember is, if you want to implement certain functions using a single ROM, for example, there are 10 Boolean expressions, you want to implement those 10 expressions using just only one ROM. Then the technique is, the function variables will become the inputs of the ROM and the number of functions will become the number of outputs for the ROM. So don't forget this, okay, because there are a number of questions related to this in the GATE exam, in the other competitive examinations, okay, which you will find. Now coming to sequential. In the sequential also there are certain techniques, but interconversions, there are some shortcuts. Just now I have solved one question. Yes, you can see that interconversion. Okay, there are some in the problem. There are some shortcuts and tips and tricks. Okay, that will be dealt in detail in the classroom course. But now, if you just see, whenever the students are dealing with finite state machines or with the counters, they will find some difficulty or any sequential circuit problem, okay, mixed with some AND gates, OR gates, some flip flops or some states. Okay, here you should remember one thing. When you are doing sequential analysis, always remember you have to focus on the present states as well as the next states. For example, there is some question, okay, there is some circuit given, some circuit with some flip flops and some clock signals and some gates are connected, some feedback is there. Now he has given after 6 clock pulses what is the state he is asking. So then during that type of questions what you have to do is you have to find out the present states, you have to find out the next states. How to find out the present states, how to find out the next states? For each flip flop you take and try to get the next state equations. Get the, for every flip flop get the next state equation, the Qn plus 1 equations, alright. And what you do is you just make a table, okay, with the present states and the next states, right. Get all the possible present states and the next state, okay, the table you can make by knowing the next state equations. So if you know the present states and if you know the next states, then you know how the states are changing for every clock pulse and easily you can, okay, solve the problem. So remember, while doing sequential analysis or problems related to those, always try to get the next state equations, make the table between present state and next states and try to solve the problem. This is one of the techniques, okay, for solving some of the sequential circuits. Next coming to data converters, R to R ladder tricks. In the data converters, especially when you are dealing with digital to analog converters, DAC circuits. In the DAC circuits again there are so many ladder circuits which are called as R to R ladder circuits. In most of the R to R ladder circuits, okay, in most of the R to R ladder circuits there is a simple technique, okay, no need to remember those, okay, complex circuits also in solving problem. Whenever a gate question comes in these R to R ladders, remember a simple shortcut I am telling you, the output V0 is for most of the ladder circuits, one ladder circuit slightly it will be changed different, but for most of the ladder circuits, okay, it is R into G into D, this is a shortcut. If you want to find out the analog output V0, it is R into G into D. What is this R, G, D? R is called as a resolution of the DAC, it is the resolution of DAC circuit. And remember, the resolution of the digital to analog converters and the two R to R ladders in particular, it is given by VR by 2 power n. Remember this, where VR is the reference voltage. This is the resolution formula for R to R ladders. And next is the gain. This gain factor will be coming from the op-amp circuit in the ladders. Almost all the R to R ladder circuits will contain op-amps. For certain R to R ladder circuits, for certain D to A converters, you can remove the op-amp. If you remove the op-amp in that ladder circuits, then gain you take it as 1. So gain factor will be coming from the op-amp circuits. If it is a non-inverting, put that gain. If it is inverting amplifier, put that gain, that's it over. So gain easily you can know. D stands for decimal equivalent of binary input. It is decimal equivalent of binary input. So what is this decimal equivalent? Since we are discussing digital to analog converters, okay, and the two in particular R to R ladders. So in general any digital to analog converter there will be many inputs, and there will be only one output, and that output is generally we are calling as analog output. Now it is a digital to analog converter, so digital input is given. So digital input means basically it is a binary input. So one terminal you can consider as 1 bit. From one terminal I will give 1 bit, from second terminal second bit, so on like this. So this digital input, if you put in decimal value, that is called as D. So, D stands for decimal equivalent of the digital or binary input. So, digital input, if you put in decimal value, then that is D. So, this term is basically coming from, the D is coming from input of the circuit, and the resolution is coming from the basic nature of the converter, and the gain factor is coming from the op amp circuit. If I remove the op amp, gain will be 1. So, this formula will help you a lot, it will help you a lot when you are solving R2R ladder networks. So, remember this formula, this is one of the simple tricks to solve very big ladder networks. Remember, if you try to do using normal network theory analysis, I am just telling you, if you do not want to use this technique, and if you want to follow normal techniques to solve this R2R ladder circuits, then what you do is, you have to apply Thevenin's theorem, you have to apply superposition theorem, and then you have to do a lot of analysis, and then finally you will get the output. It will take at least some 15 minutes if the ladder network is big. If there is a 5-bit or 6-bit ladder, then remember it will take at least 15 minutes. In the 15 minutes time, we can solve number of questions in gate. So, remember, tricks are very important, especially for the competitive examinations like gate, where the time is very limited. In just 3 hours, you should be able to do all the questions. So, just one question approximately it is 3 minutes you will have roughly. So, using this technique or trick, in just within 1 minute you can do it, and you can just jump to the next question. Within just few seconds you can do it and you can jump. But using normal techniques, you should spend a lot of time. Let us take, even if you are taking some 5 minutes, still it is you are wasting time. So, you have to know the techniques. And how you got this formulas and all those things? That's a complete classroom course analysis. Now, coming finally to the microprocessor. So, how to master the microprocessor? As I told previously, if you want to be if you want to master the microprocessor, the first thing is architecture. Architecture, be good at. Immediately, your main focus has to be in the programming. If you are not good at programming, you are not good at microprocessor. If you go to any software company, any embedded systems company, or any company you go in the future, or if you sit in the interviews, they will ask questions related to programming only. Why? Why only programming? Why? Because you can generate number of applications. If you are very good at programming, I am telling programming in the sense not developing big programs, no. You should be good at the basic instruction set. There are 74 instructions I told you, all the 74 instructions you should be very good. Take some time, do analysis, understand them, memorize them, practice them, do whatever you want. Just be good at all the 74 instructions. And all the 74 instructions, I told you all the characteristics, the opcodes, the first thing is a function of each instruction, the length of each instruction, the addressing mode of each instruction, and the machine cycles of each instruction and types of machine cycles, and the T states for each machine cycle. For every instruction you should know this. Then only you can be good at microprocessor, and then only you will be good at programming, and then good at microprocessor. And remember, definitely one question will come from microprocessor, and that generally it will be 2 marks question. Even if it does not come, not an issue, but somewhere it will attack you in your future. Maybe in MTech, maybe in some company, maybe in software, or maybe in embedded systems company, somewhere it will. So be good at. So if you want to master the microprocessor, master the programming concepts, master the syntax, master the instructions, then you will become the master of microprocessors. And of course, it takes some time. Everything will not come in overnight. But however, these are certain tips. These are very less tips what I have given. But when you are joining a proper classroom course, remember this point. when you are joining a proper classroom course, every technique, every concept, whatever I'll be teaching, I'll be giving number of shortcuts and techniques. Within that, using those techniques, you can just solve the questions just like that. Okay, if for example, there are 60 digital questions. Okay, I'm just taking a hypothetical assumption. For example, there are some 60 questions, and the time is say 3 hours. Generally, I am just taking something like a GATE exam. 3 hours, 60 questions. Just take roughly. Let us take all the questions are digital questions. Remember, using classroom techniques, what are I will be teaching. Using the classroom techniques, you can just solve just in within 1 hour. All the 60 questions, whatever the type of questions. So remember, the classroom course will be very effective. If you join the courses. So this is just a glimpse. This demo lecture is just a glimpse of the subject. It is not complete subject. It is just a glimpse to show what is what. But however, the complete liability will be on the student. If I am giving so many techniques and so many shortcuts and everything, and if the student is not doing anything, then it is of no use. The knowledge is simply wasted. So ultimately the credit will go to the students. So now I want to say, before winding up the session, first you join the classroom course or take some demo video, or just join the classroom course just for one session, see how exactly the faculty are teaching, and then just take a right decision. Option is yours. And all our students, most of the previous students whom I taught, they are in NITs, IITs, they got a good jobs, And remember, in the BTech you will get some concepts, but not in depth. If you want in-depth concepts, your approach should be at a competitive level, not at the surface level. Competitive level always will move to a depth. Don't learn things on surface, it is of no use. So you can learn good things, or in-depth concepts only if you have a good guru. Remember this. Guru is very, very important. If you don't have a guru, remember, you will be like a blind fellow going in the dark. You don't know what to target, what not to target. So the main purpose, I am not insisting you or forcing you to join the institute. No. Take a right decision, take a proper decision, and have a proper guru, a proper institute. An institute will be a guru for you, teachers will be guru for you. And work like anything. You will not even get a second rank, the first rank will be yours. I guarantee it. If you don't have a proper strategy, a proper planning, a proper institution, a proper faculty, a proper guru, is not possible to even qualify the GATE. So GATE needs some strategy. It is, I am telling a simple thing. When you are playing a chess, you need, every move is very important. If you make one wrong move, the complete game will collapse. You will lose that game. Whether it may be Magnus Carlsen or it may be Vishwanathan Anand, whomever it is, or you or me, one wrong step can collapse everything, complete game. This GATE is nowhere less to a game of life. So remember this. Once if you crack the GATE rank, everything will change.